that we had from that I just gave you. Okay. So let's do this. Change this to dimensions here. It says area on your paper, I think. Change that to dimensions. Somebody give me the labels. What do you want to use for variables for the sides? Whatever. X and Y. Okay. So let's try to do this. Let's try to take each clue that they give us, and let's see if we can write an equation for each in terms of X and Y, okay? So it says find the dimensions of a rectangle with the perimeter of 26. Can anybody make a equation for this using the X and the Y? Close. Yeah, 2x instead of an x squared, and 2y instead of a y squared. So it's like x plus y plus x plus y. So that's really just a 2x and 2y, okay? Okay, how about the formula for area? How about the equation for area?
X times y equals 30.
All right. So really what you have here is you have a system of equations, and I'm going to kind of lead you where I want you to go, okay? The easiest thing to do here probably is to take this equation and divide everything by 2 to get maybe a little simpler equation. So I'm going to say x plus y equals 13. So I'm dividing everything by 2. And then we have it partnered up with x times y equal to 30. Okay, so your job now is to mush these two together and to make one equation in terms of one variable. It doesn't matter if it's the x or the y, it doesn't matter. So what I'm going to do is I'm going to solve for one of the variables and plug it into the second equation. So solve in the first, plug into the second. So I'm just going to go like this. Y equals 13 minus x. So if I did that, could anybody mush them together to give me one equation? By substitution. I'll tell you that it's going to be by substitution.
X times 13 minus x.
All right, thank you. Okay, so we took out the y and put an expression of x in for the y, and now we have a quadratic equation that we're going to try to solve. So I'm going to say 13x minus x squared equals 30. Now what? You guys help me do it the rest of the way. Okay, so we could either move these over, or we could move that over. Both have advantages, disadvantages. What do you want to do? Move the 30, okay? So if we subtract 30, we're going to get negative x squared plus 13x minus 30. Right. So I don't like that coefficient of negative there. It kind of causes some problems. So you could either factor it out or you could multiply everything by negative 1. So I'm going to multiply by negative 1. So x factors of 30 that give me the inside plus the outside equal to 13x. Right. So again, a lot of these factorings, you're not going to have to do the AC method. You should be able to just look at the factors and find out the insides plus the outsides equal to the middle. So x could either be 3. So if x is 3, then y is 10. If we said x was 10, then instead of this being 3, it's 10, and then instead of being 10, this is 3. In either case, the dimension's 10 by 3. Okay. Do this. See if you can come up with two equations. Let's use x and y. See if you can come up with two equations here. Well, see as far as you can go. It's kind of similar to the last one we did. It's just not same concept, but go as far as you can go there. So let's see where you're at so far. If you got somewhere and you got a good start, let's see if that looks, if you're going the right direction or not here, okay? Okay, what about this? Couple options. Let's say x and y are variables. Are they equal? X equals y?
No. X plus 4 equals 1.
X plus 4 equals y. So we're saying the way we wrote it that way, y is the larger one, okay? Could you go y plus 4 equals x? Yep. Last period they said this. The difference between the two is 4. If one's 4 more than the other, either way, okay? And then the product of the two is going to be 96. So x times y is 96, right? So if I wanted to use these two to mush it together, then I'm going to probably put an x plus 4 right there. So let's say x times x plus 4 equals 96. And I'm going to subtract 96. And now this is one of the tricky parts in the problem. You have to look at factors of 96. 196, 2 and 48, 3 and 32, 4 and 24. Do you think that's going to give me the insides plus the outsides of 4? No, we're probably going to look for a difference of 4 here. 5? No. 6?
No.
6 and 16, but it doesn't work. 7? No. 8?
Yes.
So it's actually going to be 8 and 12, right? So I'm going to put a 12 here and an 8 here, and let's make this one positive, and let's make this one negative. So again, double checking, I've got 12x minus 8x is 4x. Now here is still a couple of issues left. Go ahead.
Does it matter which parentheses you put them in? Or no?
Like whether I put the x plus 12 on the right or the left?
Yeah.
Nope. Nope. Okay. So the solution to this would be negative 12 for this. So is negative 12 and 8 the pair of two numbers? No. If x is negative 12, the other one is 4 more than that. So if you did that, it's still not completely right. Because x could be negative 12, which meant that your pair is negative 12 and negative 8. Or x could be 8, that means your other pair could be 8 and positive 12. So there's really two pairs of integers that would work here. So you got to write both pairs down. Okay. Give me an issue that you have. Okay, I'm going to go back to the other page. And we're going to do this one right here. Okay, so first off, the formula, we're dropping an object with no acceleration, but just dropping it, a free-falling object, and the distance fallen in a period of t seconds is given here. So I'm just going to try it out here just to kind of understand the formula. So if t is 0, s equals 16 times 0 squared. It's fallen 0 feet in 0 seconds. How far has it fallen in 1 second? 16 feet. What's the total distance fallen after 2 seconds? It'd be 64 feet. So during the first second, it fell 16 feet. During the second second, it fell really a total of 48 feet. 16 plus 48 is 64. Why is it falling further during those different time periods? Because of what? I didn't hear you say. Acceleration due to gravity, right? Okay. And then after 3 seconds, it's going to be 144. So now it's falling 80 feet in that second. Okay, it's speeding up, right? Okay, so the question is, if something is dropped from this height and it hits the ground, first off, how far did it fall? 1,482 feet. So we're looking for what variable? Feet. Or are we looking for time? Time. So 1482 is a distance. So I'm going to have you plug in 1482 in for S, and then now solve this quadratic by using inverse operations. So divide by 16, take the square root, you should get about 9.6. See if you can do that. I'm going to go through one final problem here, and it's going to be it's on page 257, number 109. Okay, I need somebody out of far two rows. I want you to read the paragraph above page 250, above number 109. Okay.
All right.
Okay, go ahead and read that for me.
The channels that the average U.S. home receives has been soaring in recent years. The function t of x equals 0.16x squared plus 0.4x plus 21.36 can be used to estimate this number, where x is the number of years after 1985. Use this function for exercises 109 and 110.
Okay, so really in this problem, it really is important that you know your variables. So just can anybody tell me what is T standing for? Channels, right? It's TV channels. Okay, and then what is X equal to? Years since 1985. Okay. So what I want you to do is I want you to graph that on Desmos. Okay, graph that function. Let's go y equals. Just go ahead and put y equals in. And just kind of squeeze it, pull it, stretch it until you can see, kind of see the graph. Now, if we were to answer this problem the old-fashioned way, and it's a lot of work, you'd plug in 130 for what variable? You'd plug the 130 in for the t variable, and then you would solve that using the quadratic formula. But our calculator is kind of cool, because our iPad's kind of cool, because we could just maybe initially look at it and say, when is it going to get to 130 channels? It's going to get to about 130 about right here. Right? So what's 130? Not x, not the time, because x is the time. So plug in y equals 130 right here. And then that coordinate is where on the function the y is 130. I got about 24.66 for the intersection. Your function might be just, it might have a decimal or a sign or something wrong on it. This is right.
Oh.
But I would not accept 24.66 as an answer. Because the question is, in what year did the average U.S. household have 130 televisions? What is it? 2010. Okay, so let's check it out. So what if I plugged in a 24 here? Is that 130? How about 25? Now our average TV amount is over that 130 measured. Look at where the point's at. So it doesn't get above that at 24. It doesn't get that after 20, it does after 25 years. So I would say 25 years after 1985, which would be 2010, is your answer, okay? So I want a year, I don't want a decimal portion of a year, because they're calculating the data every year.
Say between 2009 and 2010.
No, I'm going to say a year. Is the year 24 years after 1985 and 2009? No. Is it 25 years after that time? I'm going to say yes. Okay. So you're going to use your calculator, your iPad to do number 107, 108. Okay. Do a couple today, put the rest away, come back and do the rest of this tomorrow. Okay.